So in conclusion, solutes from the desalination leftover salt, which we call concentrate, can be used as a substrate to capture carbon dioxide gas and turn it into a solid, preventing it from going into the atmosphere to contribute to climate change. The process combines brine electrolysis with CO2 aeration to form solid carbonate minerals. You can interface this technology with algae for biofuel carbon recycling. It's not so much carbon sequestration when you make a biofuel as it is carbon recycling, but it is possible to use some of the sodium bicarbonate to feed CO2 as well as alkalinity to algae as needed. The brine discharge is eliminated because you're producing solid carbon, and freshwater production is increased because if you can use up all the solutes out of the solvent brine that's going into the ocean, you get the solvent water from that brine solution as extra fresh water. You're also stack capturing the water that's combusting from the fossil fuel in the power plant, and you have water treatment on site. And there's a little bit of water return from the combustion or electrolytic oxidation of the hydrogen. And my final conclusion, it wasn't enough for George Washington Carver to discover the benefits of crop rotation using legumes to return nitrogen to the soil. In order to convince farmers, he also had to produce something that the farmers could profit off of. He needed to produce a market, particularly for peanuts, and that's how we got peanut butter. In that spirit, I'd like to offer this, that the sodium bicarbonate that we produce in industrial quantities could be used to replace sodium chloride, which is currently used as a de-icing agent in the northern Midwest to take ice off of roads in the snow belt. The problem with sodium chloride is as it dissolves, it produces sodium cations and chloride anions in the groundwater. And the sodium reacts with soil minerals and is used up in the environment fairly readily. The chloride, on the other hand, is conserved and it builds up over time. So in regions using road salt, chloride levels increase at about twice the rate of the buildup of sodium. If we instead used sodium bicarbonate, basically baking soda, from this desalination process, the bicarbonate anion, as opposed to chloride, if you dissolve baking soda, you get sodium and bicarbonate, is beneficial. It increases groundwater alkalinity, and particularly in groundwater areas that are impacted by acid precipitation or perhaps acid mine drainage. Bicarbonate can be used to neutralize that acid, increase the alkalinity of the groundwater, which is definitely a beneficial thing. Whenever bicarbonate, of course, encounters acid, it goes into CO2. But in general, if you're introducing bicarbonate in a stable environment, it's a good thing. It doesn't go into CO2 unless it encounters acid. It's basically a buffering component, and it's a very, very environmentally friendly anion to have instead of chloride. So I'm suggesting that we use sodium bicarbonate to replace sodium chloride as a de-icing agent, and we would be producing a lot of this if we did ocean desal and made carbonate mineral. Some of the drawbacks, as I mentioned, the energy penalty is a little bit high, but again, it's lower. It's proprietary information with Skyonic as far as what their actual energy penalty is. They indicate that it's quite a bit lower, considering that they're operating at higher temperatures. But we do have an energy penalty. All carbon sequestration processes have an energy penalty. Even just gathering up CO2 and injecting it in the ground takes energy. It takes the energy to gather it together. There are industrial hazards. As with any carbon sequestration process, these are industrial processes. Make no mistake about that. There's a lack of a market demand for chlorine products, and that could require some kind of chlorine sequestration. And some other techniques that I discussed briefly can produce more stable carbonates, especially those that use divalent cations, such as Klaus-Lackner's magnesium carbonate method, and perhaps even Calera's attempt to make calcium phosphate. The problem is that doesn't consume salt. So this process is strictly or is best used with a source of salt, sodium chloride, and it would be beneficial to couple it with brine desalination for that reason. And brine desalination is a better terminology than ocean desal because a lot of regions are going to be producing fresh water from otherwise salty sources, including brine groundwaters. Desal, it's not just for oceans anymore. And there are certainly jobs for water professionals related to this. But as we look in particularly the southwest United States, when we look at declining freshwater levels in our reservoirs, there are proposals to use heavily salt-laden groundwaters and to do desalination on these to produce the fresh water that we need during droughts.